Hey, so we're moving on. In this video, instead of just transforming one variable, we're going to be combining random variables. So I've got two things already set up. We've got, for the dealership, randomly selected Friday. They might sell 0, 1, 2, or 3 cars. And here's the probability that they sell those amount of cars. The expected amount of cars sold is 1.1. And then on this distribution, we've got variable y, which is the number of cars leased at the dealership. So on a randomly selected day, probability that they lease 0 cars is 0.4. Probability that they lease 1 car, 0.5, leading us to an expected value of 0.7. So you could say something like on 10 randomly selected days, they would be expected to sell or lease 7 cars. The average amount of cars leased is expected to be 0.7. Okay, so we're doing this new variable, T, the total number of cars sold or leased at the dealership. So this is a really important piece here. We're only going to be able to do these problems down here if we know that X and Y are independent. And that's what it just told us. I guess like real briefly, I can try to explain why that is important. So what we're doing for this variable T, the total, you don't have to write this down what it means or anything, but like we have T and the probability of T, of the total amount. So it looks like we can have the total amount of cars sold or leased be 0. We can sell 0 cars, 0 leases, and have a total of 0. So to get that probability, we would have to assume that these two events are independent in order to multiply them. So that would be 0.3. Actually, I already got one down there. 0.3 times 0.4 or 0.12. Fantastic. Okay. Now this next number here would be 1. Total number of cars sold or leased is 1. There's a lot of different ways to come up with this probability. You could have 0 cars sold. So we would do 0.3 times the 1 car leased, which is 0.5. And then we could also have the opposite situation. We could have 0 cars leased, which is 0.4, times the 1 car sold, which is 0.4. And then we would just add those two things together. So 0.15 plus 0.16. Now again, I was only able to multiply these things if I knew that the probability, or that the events, I should say, were independent. If the probabilities changed, like if I knew that I sold 2 cars and that decreased the probability that I was going to lease a car that day, we would not be able to do this. Those conditional probabilities change the effects of one or the other events. So the only way to make this table work with the information given is if cars sold, cars leased were independent. And you could just keep this going. It looks like it would go up to 5. 5 would be the maximum amount of cars sold or leased. I do not want to go through every combination. So yeah, feel free to do that on your own though. Okay, so anyways, find the mean of T. This is really easy to do. For the mean of a sum is just equal to the mean of X plus the mean of Y. For the means, we're just going to write one more formula down real quick. The mean of a difference. So if I was subtracting variables, same situation, you would just get the two means from the random variables that you're subtracting and, subtract them. So the means are really easy to work with. That's like all there is to it. So for this one, obviously, we're just doing the total amount. We're doing the sum between the cars sold and cars leased. So the mean for T would be equal to the mean for X plus the mean for Y, which means I'm just going to add 1.1 to 1 or 0.7, giving me 1.8. That would be the mean for T, 1.8 cars sold or leased. So should be pretty easy to do that part, right? Like nothing to it. Now standard deviations are Definitely a little bit more like, not so easy. Standard deviations, their formulas are like kind of crazy looking, but that's okay. We'll get through it. So standard deviation. Standard deviation. One thing to get right off the bat here. Standard deviations do not add. You can't add or subtract, for that matter, standard deviations. What you can do, if I was trying to add two random variables together, the standard deviation of their sum would be equal to, and I can't add their standard deviations. What I can add is their variances. I can add the variance of my first variable to the variance of my second variable. Then, of course, to go from variances to actual standard deviations, I can take the square root. So there we go. That's what we'll have to do to find the standard deviation of combined random variables. The difference works pretty much exactly the same way. If you're finding the difference between two random variables, this is what you would have to do. The square root of the variance added together. So you might be thinking, well, hey, if I subtract one variable from the other, shouldn't the standard deviation go down? My response to that, of why this makes sense right here, just remind yourself that more variables, if I start just looking at more variables in general, more variables leads to more variation. So even though we're subtracting the amounts, we'd still have more variation in total. More variables, there's going to be more results to differ. Like you just look up here, I've been looking at more ways that I can differ than where I started. So that's kind of the idea behind subtracting. You're still going to add the variances and then take the square root. For this situation, though, we are doing a sum to get our standard deviation. The standard deviation for t is going to be equal to the square root of our variances. So we've got the standard deviation for x right here, 0.943. But I need to convert that to a variance. So I'm actually going to square it. Remember, variance is just a standard deviation squared. So I'll do the same thing for standard deviation for y. It gave us 0.64. Jot that number down real quick. And remember, I need to go to a variance. So I need to square that amount. Fantastic. That's a job for the calculator to do. Standard deviation for the total amount of cars sold or leased is equal to, you could definitely just do this all in one go. Square root of 0.943 squared plus 0.64 squared, and there we go. I'll just round to like the nearest hundredth on this one, 1.14. Okay, so we would know that the average variance to this mean of 1.8, well, the typical amount of cars that we vary by is 1.14 to this mean of 1.8. So that's really the gist behind combining means and standard deviations for random variables. So a couple of things to really make sure that you're aware of. X and Y, whatever two variables you're combining, absolutely have to be independent. If they're not independent, then you wouldn't be able to create a distribution like I was doing here. Another thing that I think is very common to see, students just add standard deviations, subtract standard deviations, but that is never true. You can add variances to get a new standard deviation. And even if you're subtracting variables, you're finding the difference between them, you still have more variables, so you're still going to have more variation altogether. That's why we're adding the variances here. All right, I think that'll do it for this video. I'll see you all in class. Thanks for watching. Bye.